The man makes a fist. Run. This is a real-time Flux Kontext generation on a 4060 laptop GPU with 8 gigs of VRAM. 2 seconds per iteration is insane speed on my setup. This is possible using the Nunchaku install for ComfyUI. I'll show you how to get it set up, compare results, and see if the quality backs up the speed. Let's get into it. Okay, first thing we're going to do is install Nunchaku. Once you're inside ComfyUI, you want to go into the manager. Make sure you have the latest version of the ComfyUI manager. If not, you can do an update all. Just make sure you update everything, including ComfyUI, and then do a restart and then start it back up again. But once you're on the latest version, now you can go into Custom Nodes Manager and you should be able to find Nunchaku in here. So from here, you find the custom package, click install. On the version, usually you pick the nightly. That should be the latest one. Select and then just let it do its thing. You'll see that it has a restart required, which is normal for most of these custom nodes. From here, you can click restart, confirm, and in the background, it'll do the install in the command line. When the package is finished installing in the backend, you'll get the confirmation message that you have to refresh the browser once the server comes up. Just do that, reload, and your ComfyUI should pop back up. You can go back into manager just to make sure everything's installed correctly. Custom manager. And if you search for it again, you should have these options now instead of the install. And that means that you've installed it properly. So once you have this, the next part is to install the wheels. You can grab the workflow from the Nunchaku site, and I'll link it in the video description below. I've already downloaded it and put it in my workflow folder. It's called the install wheel. Just open that up. Once you open it up, you'll see a couple of nodes. The Nunchaku wheel installer, that one, you can pick the source. So I picked the Hugging Face one. You can choose either between the GitHub repo, Modelscape, or Hugging Face. I just generally use Hugging Face. Then make sure you're on the latest version, 0.31, and then you run it. Once you run it, it'll figure out which Python version you have, which Torch compiler you have, and then download the correct one and install it from there. Just make sure you do a restart on ComfyUI when you do that. So just do a restart. Let the server restart and then just refresh the page to reload. Once the custom node is installed, you need to install the Nunchaku wheels. In order to do that, you got to go to their Hugging Face page. 0.31 is the latest version of Nunchaku. And then you need to look for which Torch version and which Python version. So for me, I have Python 3.12 and also Torch 2.7 and also using Windows. So I'll take this one. You want to click it, then copy the download link, and this will be important later when you paste it into your command prompt to run it. Once you open up your terminal and you're inside ComfyUI, you activate your virtual environment, and you do a pip install, and then copy and paste the link that you just copied. And that's it. The last thing you need is the model. So you need to download the specialized Nunchaku quantized model for it to work. So if in this link in the Hugging Face page, they have the Int4 and the FP4. The FP4 I think is for 5000 series GPUs and up. So I only have a 4060. So I'm going to download the Int4 version and then use that as the model instead of the usual GGUF or the FP8 that we're using before for Kontext Dev. Nunchaku also has other ones for Flux Dev itself for the image generation model, so you can download that too if you want to play with that. Once you download it, just make sure you save it to the Diffusion models folder. Okay, the Nunchaku workflow is basically the exact same workflow that I've used previously for Flux Kontext Dev. The only new addition that I've added is from the Nunchaku custom nodes, and it's only one node, the Nunchaku Flux DIT loader. This is the one that replaces the GGUF or the Diffusion model loader. And they have a few options in this. Usually just leave a default, it's fine. Once you've downloaded the correct model, just choose it in the model section. Leave cache threshold to 0, although there's helpful hints that give you some ideas if you have different GPU setups. I left mine at 0. Attention, Nunchaku FP16. There's also flash attention too, but from the notes it says Nunchaku is faster. I left it there. CPU offload, if your CPU can handle it, or if you have very low VRAM, just turn it on, which is what I did. Device ID, leave that default. For data type, I left it as bfloat16. And then I2F mode, I just left it enabled. The rest of the setup is almost exactly the same. The only thing I added for that intro run was the Turbo Alpha LoRa. So the Nunchaku model also works with the speed up. So for this one, you'll see that the K sampler only takes 8 steps, which is how we got that super speed that I showed off in the demo earlier. But for the rest of the generations for the comparison, I turned it off to give it a more level playing field. So I put this to bypass and then set this back to 20. Otherwise, for the rest, dual clip loader, same as before, one clip, one T5. Choose Flux, and then device is default or CPU. But the benefit for Nunchaku is it uses very little VRAM, so you can usually put other things on the VRAM too if you have extra space. The same VAE, and then the same section for the load images. So again, I changed the default Flux Kontext to the regular load images. I included 2 of them, the image stitch, the context image scaler, same prompt as before, same prompting style, and then all of that gets fed up into the conditioning, which is also the same. So now your latent image is converted into the reference latent, added the prompt into it, flux guidance 2.5, no negative conditioning, and then all of that is fed into the K sampler. Again, for here, for seeds, just for this generation, I left it on fixed, but otherwise I stick with randomize. 20 steps, CFG1, Euler, simple, denoise at 1. All standard compared to the regular Flux Kontext. And we see how well it did just for that simple prompt. So it did make the change just like how I was expecting it, and that was using the Turbo Alpha LoRa. I think if you're making really simple changes, it's good to experiment with that turned on. Then you can do a lot of different generations really quickly to see if you're getting the results you want. That's typically how I was using it. I would generate a lot of different iterations to see if Kontext can actually do that edit. And then if it's a good one, I'll save the seed, then reference that seed back onto a regular generation using a non-Nunchaku model. And the reason I do that, and I'll explain later, and it'll be a little bit clearer once we go into the comparisons. I think there is a quality drop-off using Nunchaku, but really the benefit is just how many iterations you can do and how many edits you can do to find the one that you're looking for. Okay, let's go over some comparisons between previously generated images and the new Nunchaku ones. First one, change the car color to shiny metallic gold, change the background to a luxurious villa and fountain. The original image again was a red car and just a parking lot. And the ones on the left are always the ones that I've previously generated if you want to see them in the previous videos that I've made. So this one, the Q6 GGUF is definitely better and more closely resembling the original car. There's some details around the hood that it's smoothed out that's not in the original. It's changed that quite a bit. The lighting also is not as detailed compared to the GGUF. And then the background, the water is just slightly less detailed, but really the background is kind of blurry for both of them. So for this one, the Q6 is definitely a better generation. The second one was just a woman wearing armor, and this one was changed the style to Studio Ghibli anime while maintaining the same subject and composition. Again, the Q6 is on the left, Nunchaku is on the right. This one is very close. There's not much in it, I guess because the image is quite simple. The armor detailing on the Q6 is definitely a little bit better. It's less gold, less kind of fine details in the Nunchaku version. And then in the back of the cape, there's more shadow detail, more lines, compared to this one where it's just more smeared. But other than that, I mean, this one is kind of usable. The face is a little bit more detailed, has some blush here where you can't really see it on the Nunchaku version. Then the next one, change the background to snow-covered glacier. Add snow to the heads and shoulders of the man and woman while keeping the subject's faces and clothes the same. So this was the dune shot. And the original one had quite a lot of snow. The new Nunchaku one actually looks a little bit better to my eyes. The previous one was also overcooked a little bit, and this one toned the coloring down. Not really sure why I did that. All of these were generated using the same seed as the original image, so it should keep it as close to the same generation as possible. Yeah, so on top of their heads, just less snow. You can see more of the hair here. Everything else is okay, I guess. Yeah, I actually prefer the Nunchaku version. The details are just a little bit less sharp, but both of these, I mean, all of these images you'll have to fix and post a little bit and upscale. This one was taking the Labubu and then putting it into an environment. Change the setting to a restaurant. The plush toy is eating spaghetti. Also not much difference to this one. I mean, the spaghetti eating is pretty bad on both of them. The Nunchaku one kept a bit more details actually on the face. The fur detailing is a little bit better on the Q6. The pasta looks, the same. Most of the stuff, everything else looks pretty similar. This one is one of the biggest differences that I saw when I was generating. This was taking a black and white photo, then change this to a lightly colored photo of the Eiffel Tower being built. Keep the subject, composition, shading details, and textures exactly the same. There's a lot of detail lost on the Nunchaku one. I don't know if it's because it's just the original image wasn't very sharp to begin with, but it's missing a lot of things like the little hut in the middle is gone. And then the ground is just kind of a smear, a lot of pixelation versus the Q6 one. That's just a lot better and closer to what the original was looking like. A lot of the straight lines kind of just turn blurry and blocky. So for coloration, I don't think I would use the Nunchaku, and I would just stick with more steps on the regular versions. And then finally, the last one. I actually thought this one was gonna fail pretty badly, but it did. This one ended up being like one of the best ones. Remove the man from the scene and make the woman in white wear the black t-shirt with logo. Keep the style and logo of the black t-shirt the same. Keep the woman's face and pose the same. So this was a two-part image or two images referenced into one, and then context merging the two. So the woman was originally wearing a white t-shirt. There was another reference of a man in this black t-shirt, and then it did the swap onto the woman. This one is almost exactly the same. There's just slight, maybe very, very slight detail loss on the face, but the shirt, the pose, yeah, especially the shirt, because the detail is about the shirt on this edit, and that kept it exactly the same. No detail lost on the hand. It's pretty impressive on this one. So I think in general, the Nunchaku ones are definitely not better quality, but the generations are so fast that I would just use it to figure out what the best edit prompt is, or find the best seed, and then use it on a regular model with more steps once you get something that you like. So I hope this video was helpful. Give it a like, subscribe if you like this kind of stuff and want to see more, and I'll catch you in the next one.